The NDA of a line capital AB is in horizontal plane and 25 mm in front of VP. The end capital B is 10 mm in front of VP and 50 mm above HP. The distance between the end projectors when measured parallel to the line of intersection of HP and VP is 80 mm. Draw the projections of the line capital AB and determine its true length and true inclination with HP and VP. So this is the problem. Again, first we are going to take up the 3D analysis. The NDA is in HP and 25 mm in front of VP. As we see NDA is in HP, obviously the image will be seen in the vertical plane. You can see that A dash is on vertical plane and 25 mm in front of VP. So when you look from the top view, in front of VP distance of 25 mm is seen in the horizontal plane. So that is small a. The NP is 15 mm in front, 10 mm in front of VP. So when you look from the top view, in front of VP distance can be seen in the horizontal plane. So you can see that in front of VP is 10 mm, which can be seen here, and 50 mm above HP. 15 mm above HP can be seen in the horizontal vertical plane. So when you look from the front view, you can see the distance of 50 mm above HP. So the distance is seen in the vertical plane. So you have the locus of B in the front view and 10 mm in front of VP. So you have the locus of B in the horizontal plane. The distance between the end projectors when measured parallel to the line of intersection of HP and VP is 80 mm. So we have one projector which is the end projector which is A and the other end projector which is B. So that is this distance. So from this point, from this line to this line, you have the distance between the end projectors which is 80 mm, which can be seen in the top view and also we can see in the front view. So when you draw this, then what happens is both will going to cut at this point and also at this point. So you have B dash and we have B. Then join A to B with a dark line and A dash to B dash with a dark line. So we know this is the, so when you take this, so NP is in front of VP by 10 mm, NB is above HP by 50 mm. So you can see that point is here. So when you draw this with a dark line, so this is the line which is in space. That is capital A and capital B. Now we need to find out the true length. To find out the true length, it has to be parallel to any one of the vertical plane. So if you want to find out the true length in the vertical plane, so you make the line which is in space, that is capital AB, you make that line parallel to VP. So that means capital A and A is in front of VP by 25 mm. And similarly, NB is also should be in front of VP by 25 mm. So that means with A as center, you rotate this B such that it goes to the new position, which is B1, capital B1. So both A and capital B1 are in front of VP by 25 mm. Then only that is parallel to VP. So when you look from the top view, we can see that that image will go to falls on the horizontal plane. You can see AB1. Since you are rotating in space like this, the image when it is look from the top view, that image will be rotated in the top view from B to B1. So then when you look from the front view, that is projected onto the locus of B in the front view, which is B1 dash, and A dash is already fixed. So then join A dash B1 dash. So this is the true length of the line, which is inclined to HP. So you measure that angle with respect to that, it should be theta. So now, once we find out the true length in the vertical plane, now we need to find out the true length in the horizontal plane. To find the true length in the horizontal plane, you make that line parallel to HP. So that means and A is in HP. So B should also lie on HP. So with A as center, by taking AB as the radius, you rotate it and make it parallel to HP. So that means NDA is in HP. So that B2, capital B2 should also lie on the horizontal plane. So now the line is parallel to HP. So that means when you look from the top view, you get small AB2. This is the line which is parallel to HP. So that means you are going to get the true length in the horizontal plane. So what will going to happen? So when it is rotated in space, actually what happens when you look from the front view, that image will be rotated from with A dash as center, A dash B dash as the radius. You rotate it, make it such that B2 is on, B2 dash is on HP. But A is already on HP. So when it is projected, it will be projected onto the locus of B, so that you are going to get this B2. A is on HP, B2 is also on HP. So now the line is parallel to HP. So you are getting the true length in the HP. So you write capital A and capital B2. So which will be on the locus. So you are going to get this line will be in true length. Now this is how we can be able to analyze this in the 3 dimension. Now we will going to take the step by step. So first we will going to consider NDA is 25 mm above 25 mm in front of VP. The distance is seen in the horizontal plane, and NB is in front of VP by 15 mm, 10 mm. So this is the locus of B in the front view, top view. And similarly, when you look from the front view, NDA is in HP, so it is on VP, and then NB is 50 mm above HP. That images can be seen in the vertical plane. So you have the locus line in the front view and you have the locus line in the top view. Now you know that the distance between the end projectors is 80 mm. So 80 mm we can see in the top view. So when you draw this, so you are going to get this point, cutting the point at the locus of B in the top view. So then join A to B, which will going to be the top view. So then what we do, so when you are projected it into space, you can see this B is above HP by 50 mm and in front of AP by 10 mm. So this is the line which is going to be in space. So you rotate this AB, make that B and AB1 should be A and AB1. A and B1 should be in front of AP by 25 mm. So when you look from the top view, so that image is rotated like this. So you have AB1 parallel to VP. So when it is projected, you are going to get this point. So you are going to get the true length in the vertical plane. So this is theta. So similarly, so when you are looking in the orthographic view, you have the XY line. So you can see NDA is in front of EP by 25 mm, NDA is in HP. NB is 10 mm in front of EP and 50 mm above HP. And we know the distance between the end projectors is 80 mm, which is cutting both the front view and also the top view. So you are getting this line, which is capital small AB, which is the top view. You make it line parallel to VP. So you are get NDA is in VP, B1. NDA is in front of EP by 25 mm and B1 is also in front of EP by 25 mm. So now you have the line which is parallel to HP. So you are, when it is projected into the locus of B in the front view, so you are going to get the true length in the horizontal plane. So the true length in the vertical plane. So the inclination made by that with respect to XY line is theta. Now similarly, we will going to consider the true length in the horizontal plane. When you want to take the true length in the horizontal plane, you have to take the front view. That is A dash B dash with A dash as center. So this is the line in space. When with A as center, by taking the radius of AB when it is rotated and make it parallel to HP, but it is still inclined to VP. So here NDA when it is made parallel to HP, so you are getting the true length in HP. So when you look from the front view, so since it is image is rotated in the vertical plane, so it is in space. So the image is going to fall on the vertical plane by looking from the front view. So and when you, that is NDA is in HP and B2 is also on HP. So since the line is parallel to HP, so you are getting the true length in the horizontal plane. So when this is projected onto the locus of B in the front view, in the top view, so you are going to get AB2 and join A and B2 with a true length line. So this is how you will be, and the inclination made by the true length with respect to VP is fine. Now we will going to take the same thing in an orthographic view. So NDA is in HP and 25 mm in front of VP, and NB is above HP by 50 mm and in front of VP by 10 mm. So we know the distance between the end projectors. I will always cut the locus here. One point will be here and the other point will be here. So you mark this point as B dash, join A dash B dash with a dark line. And also this end projector will going to cut this locus. So you will get the point small b. Then join A to B with a dark line. So we have to make it the true length in the horizontal plane. You make the line parallel to HP. So NDA is in HP. And B also should be on HP. So with A dash as center, by taking the radius of A dash B dash, you rotate such that both A dash and B2 dash will lie on the XY line. Then project the vertical projector from B2 dash to the locus of B in the top view. So you're going to get bottom point A, B2. Then since it is horizontal plane, then it is parallel to HP. So you're getting the true length in HP. You make that point as capital A and capital B. Then join A to B. Then find out the inclination made by that with respect to the vertical plane, which will be fine. Now this is how we will be able to solve the problem. You will be able to analyze the problem in 3 dimensions. Solve the problem in orthographic view. So to do that, so here first we will go to draw the XY line and mark VP and HP. So this is what we are trying to do in the sketchbook. So first Consider from xy line the distance of NDA is in HP. Consider any point on the xy line and you mark that point as A dash because NDA is in HP, so the image is seen in vertical plane. So you take A dash and 25 mm in front of EP. In front of EP distance can be seen in the horizontal plane. Since HP is below XY line, from XY line you measure 25 mm and draw a horizontal line. And then consider any point and draw a vertical projector which will going to cut the locus of A in the top view. So you mark this point as small a and you mark this point as A dash. And then the NB is 10 mm in front of VP. So in front of VP can be seen in the horizontal plane. From XY line you measure 10 mm below the XY line and then draw a dashed line which is going to be the locus of B in the top view. Similarly, NDA is B is 50 mm above HP. So from XY line you measure 50 mm and draw a horizontal dashed dot line which will going to be the locus of B in the front view. Then the distance between the end projectors when measured parallel to the line of intersection of HP and VP is 80 mm. So we are already considered one line which is the end projector. So the distance between the end projectors means the distance between both A dash, B dash and AB both should be on the same line. So from B dash you draw so from here you measure 80 mm and draw a horizontal vertical line such that it will going to cut the locus of B in the top view and also the locus of B in the front view. So you mark this point as B dash and you mark this point as small b. Then join A to B with a dark line and A dash B dash with a dark line. Now we know to find out the true length in the vertical plane with A as center by taking the radius of AB by using the compass. Then draw an arc such that both A and B1 will be parallel to XY line in the top view. Once it is parallel to XY line in the top view, obviously that line will be seen in the true length in the front view. So since you have B1, so from B1 draw a vertical projector, vertical thin projector which is going to cut the locus of B in the top view or in the front view. Then mark this point as B1 dash and then mark this point as capital B and capital A. So then join A dash B1 dash with little bit thinner than the front view line. Now similarly, then the inclination made by the true length with respect to HP is theta. You show the dimension and mark the dimension as theta. Similarly, now we need to find out the true length in the horizontal plane. So with A dash as center by taking the radius of A dash B dash. So by using the compass you draw an arc such that both A dash and B2 dash which will going to be parallel to the XY line in the front view. Obviously its corresponding top view will be in true length. So that is the condition which we are applying. So from B2 dash you join and draw a vertical projector which comes down till to the locus of B in the top view. Then this is the front view and this is the top view. So you mark the point as B2. Then since A dash B2 dash is the line which is parallel to HP, so you are getting the true length in HP. So you mark the point as capital A and capital B. Then join A to B to A and B2 with a little bit thinner than the front view and top view line. So this will be, you write this as capital B and you write this as capital A and you write this as capital B. So then the inclination made by the inclination made by the true length line with respect to VP is called phi. Then to write the answer, this is how we will be able to solve the problem. Now we have to check for the answer. So answer is, now you show the dimensions of 25, 80, 50 and 10 and show the inclination phi and theta, and you consider any one of the distances and make this line as true length is equal to question mark. So when you are measuring by using the scale, true length will be equal to 96 mm. When you are doing it in computer, the true length will be 95.52 mm. Similarly, when the inclination made by the true length with respect to HP is theta, theta will be equal to 31.56 when you are doing it in computer, and when you are doing it in manual, it will be 32 degrees. Similarly, the inclination made by A with respect to AB2, then the angle measured will going to be by using the protractor. You measure that angle. So the angle is 9 degrees. So you make it 9 degree here. Then when you are doing it in computer, when you are doing it in manual, it will be 9 degrees, and when you are doing it in computer, it will be 9.03. So this is how you will be able to solve this problem in the sketchbook.